When you think of astronomy, you think of optical astronomy, so looking up towards the sky with optical telescopes. But there's so much that the universe has to tell us in the radio wavelength.
There's always a want to be able to observe the universe. When you look up in the sky, you can see the stars, but for radio, we need to build something that will see for us. So in this case, we have radio telescopes that will measure these meter wavelengths, so tens to hundreds of megahertz, all the way up to almost terahertz. These are all answering different parts of these astrophysical questions. Measuring anything from the radio glow around a black hole, 50-something million light years away, to measuring something nearby, stars formation, planetary formation, and also, as far back as the early universe, 13+ billion years into the past.
NRAO is in the business of designing, developing, and building some of the most sensitive radio frequency receivers on the planet, and then tying those to some of the biggest collecting areas on the planet.
We're standing about 485 feet in the air on top of the Green Bank telescope. So we are standing on top of our receiver room. And what you can see right here is actually a bunch of different receivers. So this is our dish. It is 100 meters across, so we are a 100-meter radio telescope. And that 100 meters is actually part of a 208-meter parent parabola. So if you think about a normal radio dish, it's typically that circular dish with 4 struts that come down, and your receiver is at the center. The Green Bank Observatory is pretty unique because we have an offset feed arm, which means that we can use more of that parabola when we're doing our observations.
The mission of the Green Bank Observatory is to further the advancement of science, and we do that through using technology and equipment for our professional astronomers to make sure that they're able to get the best science data possible. And we also further that mission by inspiring young minds. So there's a lot of grade schools and Boy Scout groups that come in, and they're able to use telescopes on site, including the 20-meter and 40-foot telescopes. And we also have the 20-meter telescope, which is available for university use.
So the Green Bank telescope has a pretty sophisticated radio system. So we collect the signal at what we consider the front ends, which are the receivers themselves, which are feats of engineering. A lot of people like to do science with neutral hydrogen, which is at the 1420 megahertz line. So our L-band receiver is probably one of our most used receivers. As you get to higher frequencies, you have people studying active galactic nuclei. Lower frequencies, you have people studying pulsars. So really the full range from about 200 megahertz to 116 gigahertz is extremely important to all of our observers.
When I was a graduate student, and for most of my career, I was able to make radio observations without really thinking about spectrum use and whether or not I would actually be able to make those observations. As we enter an era where there's increasingly competition for use of the spectrum, I just wanted to make sure that future generations of radio astronomers will have clean spectrum where they can continue to make those great scientific observations.
Being able to generate and provide high-quality data, making that integrated instrument that will be able to generate and provide the answer to the questions people ask. It's very an interesting challenge that is worth solving.
I love working in this position because I get to see scientific discoveries happen right in front of me. I get to make sure that the telescope is working for these giant projects that are really on the forefront of discovery. So I've been able to see the nanograv announcement, I've been able to see people discover molecules, and it's been truly incredible to watch us as humans look up to the sky and start to understand things more.